now we are going to see this rectangular form of complex numbers. Now consider complex number z is equal to x plus iy, and we can consider as a rectangular form. So the form which is given by z is equal to x plus iy, and if this is expressed by x and y rectangular coordinates, what I said, if it is as expressed by x and y rectangular coordinates, means x and y rectangular coordinates, hence it is called as rectangular form of complex number. Rectangular form of complex number. So in Argand, ARGAND, Argand diagram, we have OP is equal to square root of x square plus y square, means this is also known as mod of z. जे आपल्याला आधी माहिती आहे की mod of z is equal to square root of x square plus y square is equal to z. Means this can be in Argand diagram, this is known as the position vector OP, which is given by square root of x square plus y square, means the mod of z, means the mod of any complex number can be represented as a position vector, and this is as when x and y rectangular coordinates describes the complex number. So we can consider the point P with coordinates x and y on xy plane, So this point represent only one complex number, right? This point on xy plane represents only one complex number. So this OP is called, this OP is called as position vector. This OP is called as position vector. So the points on x-axis, have real part, and the points on y-axis has imaginary part. Right? The point on x-axis has a real part, and the point on y-axis has an imaginary part. So this is known as the rectangular form of a complex number. So this describes the point P with the coordinates x and y, and this is also a complex number, which is z is equal to x plus I times y. So similarly, we have the second point, that is the polar form of complex number, right? The polar form of complex number. So in two-dimensional geometry, analytical geometry, a system of Cartesian coordinates, that is x and y, or polar coordinates, that is r and theta, these are polar coordinates, which are used in Cartesian coordinate system. So this is x, y, and these are polar coordinates r, theta. So we can have a different kind of structure. So we can draw a particular diagram. So if this is a x and y axis system, here this is y, this is x, this is x dash, this is y dash. The point O at origin, and we are having a point P over here, and this can be joined as this one perpendicular. So point P, P dash. So OP distance is known as R. Here the angle theta, and the distance OX, this O, this point is denoted as X, and this denoted as Y. So this kind of structure, we can consider that if we are considering a point P on this Cartesian coordinates two-dimensional system, then we can consider that this OX and OY are rectangular coordinates. So these rectangular coordinates with the origin O. So consider point P with x and y coordinates, and this point is at a small r distance from the origin. So we have r is equal to OP dash. R is equal to OP dash. So let theta be the angle made by r and x with the x-axis. Therefore, we can consider, using trigonometric relation, we can consider that this x is equal to r cos theta, and this y is equal to r sin theta. That we know these are the polar coordinates. X is equal to r cos theta, y is equal to r sin theta. Therefore, r square is equal to x square plus y square. So the complex number z can be represented as z is equal to x plus I times y. Therefore we know that we know the value of x as this and the value of y as this. So we can consider z is equal to, put these values in this equation, r cos theta plus I times r sin theta. So z is equal to r cos theta plus I times r times sin theta. So we can separate out r cos theta plus I sin theta. So this is a form in terms of, this is a complex number in terms of the real numbers r and theta. Theta is the argument, r is the real number, r and theta are the real numbers, and z can be represented in terms of the polar coordinates r and theta. This r and theta. So we can find the complex conjugate of the same equation as, so we can consider the complex conjugate. So complex conjugate means z bar is equal to r cos theta minus I times sin theta. Z bar is equal to r cos theta minus I times sin theta. Therefore, this z mod of z square is equal to z into z bar, and we know that this is the relation as it is given by the same form as x square plus y square, and we know the equation of both tools. as it is given here, this r cos theta, r sin theta. So we can put these values and we can have this mod of z square is equal to z times z bar, means z square plus y square, and we can consider put the value of x and make it square. So r square cos theta plus I times sin theta, and in bracket, so we can neglect this because we know this part. So cos theta minus I times sin theta. Neglect this, just consider this part because z is equal to this and z bar is equal to another equation cos theta minus I times sin theta. So this whole equation becomes r square cos square theta plus sin square theta. So mod of z is equal to r because the value of this is 1, right? We know using trigonometry sin square theta plus cos square theta is equal to 1, therefore r square into 1 means r square. So z square is equal to r square means z mod of z is equal to r. So this r is the modulus of complex number z, and this Argand diagram gives, because of this we can write cos theta is equal to, using this diagram, we can write this equation as, it can be written as x, we can convert this part to this part, x upon square root of x square plus y square. Similarly, we can write sin theta is equal to y upon square root of x square plus y square. And similarly, tan of theta we can write, this is the form of sin theta upon cos theta, means this is y by x. So this, in this form, the quantity theta is called phase angle, and or we can say argument of the complex number. Okay, so let's stop here.